Great. Okay, so we're moving on. We're dealing with the final exam from fall 2017, and this is question 2, also a partial fractions question. Okay, so again, we've got the integral of 3x squared minus 2x plus 9 all over x minus 1 x squared plus 4. This looks similar to the previous question, okay, in terms of our denominator. Whenever you're seeing an integral and you've got like functions like this in the denominator, you should be thinking of partial fractions. Okay, so let's write down our equation, 3x squared minus 2x plus 9 all over x minus 1 squared plus 4. Okay, so now I have a factorable piece right here, like this is I set it equal to 0, solve for x, I get x equals 1, which means I can just use a single variable, x minus 1, as my numerator. This here is an unfactorable quadratic. If you're not sure, x squared plus 4 equals 0 minus 4 minus 4. X squared equals minus 4. If I go to take the square root of it, I have a negative square root, which means that it's going to be imaginary. So it's an unfactorable quadratic. If you think you can convince yourself that it's some other form, like x plus 2, x minus 2, or x plus 2 quantity squared, please FOIL it out to confirm that it equals this quadratic here. You'll find on any of those forms that it doesn't equal this. When I have something like this, I need a bx plus c in my numerator, x squared plus 4. Okay? So now our goal for doing the partial fractions breakdown is to be able to solve for our coefficients a, b, and c. Can we do this? So now the first thing I'm going to do is I'm going to multiply both sides by the denominator here. So this becomes x minus 1, x squared plus 4. Okay, so what we get is, let's write down 3x squared minus 2x plus 9 equals a times this x minus 1 cancels here, and I'm left with x squared plus 4. Plus, make sure you have parentheses around your bx plus c, okay, to remind you that you're going to be FOILing this out. X squared plus 4 is canceled, and this is going to multiply by x minus 1. All right, so we have some low-hanging fruit in order to be able to solve for a, b, and c. So the first thing I'm going to do is I'm going to take this here. We said this was equal to, the solution to this was x is equal to 1. So I'm going to do that. X is equal to 1. Everywhere I see an x, I'm going to plug in a 1. So I'm going to get 3 times 1 squared minus 2 times 1 plus 9 equals a times 1 squared plus 4 plus, if I plug in 1 for x here, I'm going to get a 0. So this whole thing zeroes out, which is good. So this becomes 3 minus 2 plus 9. So 3 minus 2 is 1 plus 9 is 10 equals, this is 1 plus 4 is 5 times a, so 5a divided by 5, a equals 2. I'm going to put a box around it so I can remember and keep track of it later. Okay. Now moving on, I need to be able to solve for b and c. Okay, so how I need to do that is I'm going to have to group coefficients of like terms. Okay, but first thing first, I'm going to plug in a equals 2. So it's going to make my math a little bit easier. So let's go 3x squared minus 2x plus 9 equals 2 times x squared plus 4 plus 8x plus c, x minus 1. Okay, now I'm going to distribute all these things here. So this is going to go 2x squared plus 8 plus, let's FOIL this out. So this will be bx squared minus bx plus cx minus c. Okay. Now let's group our terms together. So I've got 2x squared and bx squared. So I'm going to factor out the x squared. I'm going to get 2 plus b. Right? Put a little mark there. I have a minus bx plus a cx. I'm going to factor out the x. I'm going to get c minus b. You could leave it as minus b plus c, but I just wrote it like that. Okay, so I've got this one and this one. Now my constant terms, I've got an 8 and a c. Actually, a minus c, so make sure you make note of that. Okay, and that's equal to 3x squared minus 2x plus 9. Okay, so now we need to set like coefficients equal to each other. So my x squared terms, I've got a 3 and a 2 plus b, right? They're both coefficients of my x squared. So I'm going to set those. 3 equals 2 plus b. My second equation is my x. I've got a minus 2 equals a c minus b. Okay, so that's good. And now my constant terms, I have a 9 equals 8 minus c. So I'm going to look for, I've got 3 equations and 2 unknowns. So this equation here has 2 variables in it. This one has one variable, this one has one variable. So I'm going to maybe focus on these two here. It's going to help me solve more easily. Okay, so for b, minus 2 on both sides. So 3 minus 2 is 1 equals b. Good. Let's do that over here. So minus 8 minus 8. So 9 minus 8 is 1 equals minus c, minus 1. C equals minus 1. That's good. Let's just confirm, right? So if I plug in a minus 1 for C minus a 1 for B, minus 1 gives me minus 2. Check. So that's a good check that we actually did our algebra correctly. Okay, so now our next bit is taking our A and our B and our C and then plugging them back into these equations here that we came up with at the very beginning. Because remember, the whole goal for all this is to be able to integrate our big monster 3x squared minus 2x plus 9 all over x minus 1 x squared plus 4 dx. That's going to equal to a, which is 2, all over x minus 1, I'll put a dx here, plus bx plus c. Our b was equal to 1, so x plus c, c is equal to minus 1. So x minus 1 all over x squared plus 4 dx. Okay, so like we've done in some previous problems, what I'm going to do is this one here, I can think about this as u substitution, where u equals x minus 1. My du is equal to dx. This is just 2 over u. When I integrate it, I'm going to get 2 times the natural log of the absolute value of x minus 1. Plus, I get to think about this one here. I have this x squared plus 4, and I've got 2 terms. So I'm going to break this up into 2 separate integrals. This is x all over x squared plus 4 dx minus 1 all over x squared plus 4 dx. Okay. This one here, right, x is a derivative of x squared. So I'm going to think about u substitution. U equals x squared plus 4. Du equals 2x dx. I only have an x dx. I'm going to divide both sides by 2. So what I get here is 1 all over u times du all over 2. So this becomes 1/2. I can factor out the 1/2. 1/2 natural log of u. Okay. I'm going to substitute back in that u here. So I'm going to get 1/2 natural log of the absolute value of x squared plus, oops, x squared plus 4. Okay, now this part right here, this is our inverse trig. Okay, we think about this in terms of x squared plus 1, in terms of our inverse tangent, but it's x squared plus a squared. Now our form for inverse tangent then becomes 1 over a, inverse tangent of x over a. Our a, this is an a squared, so our a is equal to 2. So what we get here is minus 1 over 2 inverse tangent of x over 2. Let's not forget to add in our plus c, and then let's bring down this here that we had from before. Ln of x minus 1. And I'm going to put a circle around it so I can keep track. Okay.